Yes. Hello student, welcome to our physics discussion, that is physics in a smart way. Last video we were discussing on constant volume process or isocoric process. Here in this video we go for its next logical extension, that is isobaric process or constant pressure process. Isobaric process, that may not be legible. My handwriting, you must excuse my poor handwriting. My handwriting is not so poor usually, but with your tab and all those things, that seems to be poor. So that is constant pressure process or isobaric. Bar is the unit of pressure. The first thing that comes in is the static equation, as you know. And you know static equation is formed out of three variables. One is pressure, volume, temperature. And because here pressure is constant, so pressure is no more a variable. So obviously logic says state equation must be consisting of two things. One is volume, second is temperature. And if nothing comes to our mind, in chemistry we have learnt of many rules like Charles' law, Boyle's law, Avogadro's law, Gay-Lussac's law. If those things do not come to our mind, we can take the help of our old friend, that is nothing but always the universal gas equation, that is PV equal to nRT. But we know here pressure is constant, so pressure goes out. Number of moles, once you fix up the gas, that is a constant. R is also a constant. So that directly says volume is directly proportional temperature. So volume is directly proportional temperature, or volume by temperature will be equal to NR by P, and that is a constant. So thereby we know that is the state equation in our case. V by T is constant. I don't remember exactly whether it is Charles' law or Boyle's law, not Boyle's law, but Gay-Lussac's law, Avogadro's law, Gay-Lussac's law, but we know with the help of mathematics, with the help in symbol, that has to be V by T equal to constant, or V is proportional to T. Second, as it is, number two, just like our last case, work done, thermodynamic work W. We know for a constant pressure process, the formula of work is very simple, that is P delta V. Apart from isocoric process or constant volume process, where there is no work done is zero, this process or constant pressure process gives us the simplest formula of work. In other cases, work is decidedly difficult because you have to go through, because pressure is not constant, so you have to go through integration or integral processes. So P delta V, but so far as P delta V is there, let me remove this because we need to work out. Sometimes work, if we like, we can keep in the form of P delta V. If we like, we can keep in different form. Just like we know, again, that we take the help of old friend, that is PV equal to nRT. We know pressure is constant. In this process, we cannot change the pressure. Only volume can be changed. So pressure into change in volume. On the right hand side, the things which are liable to change, number of moles cannot change. Universal gas constant, it is not within our powers to change. So only thing can change is delta T. So P delta V can be replaced by nR delta T. So thereby we know the formula of the work will be equal to nR delta T. If it is given in temperature form, so constant pressure work, if a student writes in the form of P delta V and helps him, it's well and good. Otherwise, it can be replaced as nR into delta T. Okay. Number three, you know, number three, that is the first law of thermodynamics. So far as first law is there, first law of thermodynamics. We know, taking it in macroscopic form, Q equal to or delta Q equal to, sorry, delta U plus W, that says if the gas absorbs some heat or if we are giving a heat Q to the gas and gas out of the heat, the gas stores delta U amount within it, that is the change of its internal energy. That gas may do W amount of work and sends energy outside, like compressing the spring and all those things. Because we are dealing with a constant pressure process, now if you consider the terms Q means the heat which is given to a gas, or maybe in opposite way, the heat that gas gives to us. We feel there is no stricture against it. In a constant pressure process, the gas can absorb some heat, gas can release some heat. So Q is non-zero. Delta U. Delta U has got a standard formula. We know that is NCV delta. And keep it in mind that change of internal energy is zero. The internal energy is a function of temperature only. NCV delta, internal energy is a function of temperature, So internal energy changes if temperature changes only. If temperature changes, then internal energy changes. And because there is no restriction on the change of temperature, already you have used delta T or something like that here. So thereby delta U can be non-zero, W. W is zero, like the last process or constant volume process, if the gas is not allowed to move, if the gas is not allowed to change in the volume. But in this process, we got one restriction, that is pressure is not allowed to change, but there is nothing on volume. So thereby Q is non-zero, Q can be non-zero, delta U can be non-zero, and W can be non-zero. So first law remains as it is. First law remains as it is. Next, let me clear up some space. Number four, that is the issue of specific heat. Specific heat, specific heat. C, as we know before, C equal to Q by N delta. Heat absorbed or heat released by the number of moles and the change of temperature. But because we know a gas can have many different specific heats, and here we are trying to find out specific heat, and our process is constant pressure process, so our specific heat will be definitely a constant pressure specific heat. So here C is replaced by Cp. C is replaced by Cp, or C must be coming with a subscript, that is Cp, constant pressure specific heat. Let me write it here. So Cp equal to Q by N delta. Cp equal to Q by N delta. Sorry. Just a minute. Other way. So Cp equal to Q by N delta, as you know, but from the third point, we already know Q can be replaced as delta U plus W. So in place of Q, I am writing delta U plus W by N delta. N del T. And here, one more step, W can be replaced as, we take the help of second step, as NR del T. In place of W, you can write NR del T. So the numerator is in the form A plus B by C, that is A by C plus B by C. So that will be equal to delta U by N del T plus NR del T by N del T plus R. One thing we can notice that delta U by N del T is a term which is not known to us, which is not unknown to us. We know it, and that is nothing but constant volume specific heat. So that is Cv, and this is R. So thereby we are coming across a very famous relationship. This formula is known as Meyer's formula. This formula is known as Meyer's formula, that gives the Meyer's formula or Meyer's equation that gives the relationship between the constant pressure specific heat and constant volume specific heat of an ideal gas. And the famous relationship is Cp equal to Cv plus R. A student of thermal science or thermodynamics must be remembering that Cp equal to Cv plus R, or sometimes we write that Cp minus Cv equal to R. Cp minus Cv equal to R. That is the relationship. I think you got it. Let me clear up some space and then we can go to the last point of ours in this case, that is the graphs. So far as graph is concerned, we do know I have to remove this Meyers and all that, so Meyers should not be angry with me. So whenever we go to the graphs and all that, three graphs, because we got a graph, we draw a graph with two variables, and here we got three variables. One is pressure, volume, and temperature, but here pressure is constant. So the first graph is with pressure and volume. Because pressure is constant, we know the graph will be like this, a straight line parallel to volume axis. Graph will be like this, pressure is constant, y is constant. Second graph also is simple. We consider y-axis as the pressure axis and x-axis temperature. Here, just like the first graph, the graph also will be like this. Just like the first graph, the graph will be like this. And third, first graph we have considered pressure volume, second is pressure temperature, and third is volume temperature. What sort of graph we'll be seeing? We can realize that if we look at the state equation, V by T is constant. V by T is constant. We consider volume on y-axis, temperature on x-axis, y by x equal to constant. That constant can be written as m or k or something like that. So y by x equal to m, y equal to mx. So that will be giving us a straight line passing through origin, and that straight line will be of a slope. Slope of the line, that is tan theta. Tan theta will be equal to v by t, will be equal to v by t. Already you have decided that. You can refer to my writing. V by t will be equal to nr by p. I won't be telling you from where I got. So that is nr by p, or else I am giving a hint. we refer to the old friend, that is PV equal to nRT, and here we know tan theta will be equal to y by x. Y is volume, x is temperature, so that is V by T. But writing V by T won't solve any of our issues, because there are many volumes, there are many temperature. But in fixed term, if somebody expresses that, that must be equal to nR by P. Okay, thank you for today. So that is about the brief idea about constant pressure process. If at least these points you keep in mind, the solving questions for constant pressure process or this related work will be very, very easy for you. You won't be stumbling anywhere. So thank you again. Thank you again. Let us